This video is for Marconi on Worldwide DX. He was asking about my antenna, my vector antenna that included a gamma match. This is the starting point. This is a vector antenna in 4NEC2 built to Homer specifications, ring height, diameters, vertical antenna length, etc. And this is basically for a comparison. A few things to look at before I load the actual model with the gamma is SWR. We will see that drop. Impedance we'll see get much closer to a good impedance, causing SWR to drop. The other two things to look at closely is the efficiency percent and the radiation efficiency percent. Something is going to happen with these two that is kind of a rare occurrence and something that I think a lot of people won't expect. One of these is going to go up and one of these is going to go down. We see their starting gain is at 3.96. I can draw up a direct comparison down there, so I'm not worried about that. Opening up the version with the gamma, taking a look at a few things. Gain did go up, as I mentioned. We'll notice the efficiency actually went down some, and the radiation efficiency went up some. We'll get to those in just a minute. Let's zooming in on the gamma match. I did have to make it a little further out than the radials. It has to do with the segment being a feed point, and certain things wouldn't work with the shorter feed point. The first thing you'll notice on those is probably the 7 blue dots. Let me zoom in a little more. I'm going to show the segments. As we can see, there's 7 segments on that wire. Each of those segments gets that blue dot. What those blue dots are is, for this wire, I've put in a capacitance value. And I also put in a loss value based on the Q of what a capacitor of that length would be. Because that's what the gamma is it's 2 wires, one inside the other. Most of them will have they'll all have a dielectric, most of them that's Teflon. I actually found a calculator for that and calculated an estimated loss amount. So that may be give or take some. So essentially that's all it is the wire comes out, goes through the feed point at that point. It goes up the side where it goes through the capacitance, change the effects of capacitance and loss, and then it comes up and taps the vertical. If we need to, I can get that length. Now on this one, we'll see another little piece up here. There's 2 reasons this is here. One, I tried it without this piece and I could not get it to tune. The second reason is when I saw pictures of Homer's antenna with his specs, at least the ones that I could find. I don't know if it was the ones built to this spec or other specs, because I know he's built more than one. It had a little piece here. This little piece is interesting when it comes to a gamma match, because without it you can only tune a certain number of impedances. With a little piece up here, and you can make this longer and shorter as needed, this can actually cause the gamma to be able to tune a wider range of impedances. The vector antenna that we have here, I could not tune without this piece here. So at least according to the model, that seems to be required. Zoom back out. Again, efficiency within the structure actually went down slightly. It wasn't a lot, but it did go down. But the radiation efficiency went up. What would cause that is, as we'll note, instead of put the segments back on that I had before, zoom in, whereas before I had the feed point here, which is right where that is, it's basically one wire attached here, the coax attached here, one wire attached here. The radiation pattern was based partially on that. In this case, the radiation pattern is based on a wire here and a wire here, and the gamma is making changes to that before it goes here. That is changing the current distribution of the antenna, which is why the efficiency of the structure can go down, but radiation efficiency can go up. Now I'm going to minimize this, and I'm going to open up another program. I also modeled these antennas in a program called Managal. 4NEC2 uses the NEC2 engine. The Manigal uses the mini neck engine. I'm going to go into the comparison. We're going to load Homer and then the Homer with the Gamma. Let's see if we can show which of those is which here. So we can see the top one is the base model, the one in black. The one on the bottom is the version with the gamma match. And we see very similar results from one software to the other. We see an SWR that's a little over 3.5. It's actually 3.61 as opposed to 3.59. And that goes to about 1.2 to 1.3. In one case, in the 4NEC 2, I was able to get it to 1.22. In MiniNEC, I was able to get it to 1.29. Gain also went up about the same amount. Let me put in a comparison just so we can see how close those are. So with 4NEC 2, we went from 3.96 to 4.09. With MiniNEC, it went from 4.09 to 4.19. Again, about the same. There's a little more gain showing with 4NEC 2 than MiniNEC. In MiniNEC, in this case, in the Manigal version of MiniNEC, we're actually able to see a slight elevation difference because of the gamma. The radiation angle goes up by 0.3 degrees. You'll never notice that in real life, but in this software, it actually calculates the angle to tenths of a degree as opposed to the original MiniNEC and the NEC 2 based engines, which go to 1 degree. They're both over, in both cases, real ground. Don't worry about this height here. This height was factored in. What you can do is design an antenna at ground level and then change the height elsewhere. I did not have to do that. Now I'm going to close this, go back into the model. Actually, no. We wanted. Did I minimize? I minimized it. Okay. Now I know Eddie or Marconi, you're gonna say something about there being no mast here and the model being flawed because of it. There's actually a reason why I put no mast here. I want to point that out. If you want me to explain that, that would take an explanation outside of this. The short story is the real ground when it comes to the NEC 2 engine, that's 4NEC 2 and EasyNEC. Whenever you have a wire that directly attaches to the earth, it doesn't actually model it accurately. So just throwing that out there, there's a more complicated explanation. I don't know if I'm going to get into it at any point. But yeah, that's that. Hope this helped.